Okay, let's solve some questions. So they say a pizza shop offers a build your own pizza option with 8 different toppings. If a customer can choose 4 toppings for their pizza, how many unique combinations of toppings can they select? So in this case, no specific order is given to us, right? They don't tell us we need cheese and then we need sausages and then we need bacon, right? There's no order. So when we have these type of questions, how many different topics do we have in total? Well, we have 8 different topics in total, and I can choose 4. So we want to find combinations. Now, the formula for combinations is simply NCR is equal to n factorial over r factorial multiply n minus r factorial. So let's go solve this question. In this case, I have 8 factorial over 4 factorial multiply 8. We have 8 minus 4 inside the parentheses factorial. That gives me 4 factorial. I can simplify this by saying 8 times 7 times 6 times 5 times 4 factorial over 4 factorial times 4 factorial. Cancel, cancel. Again, a little bit of revision. What does factorial mean? It simply means all the numbers in the set have to multiply with each other until the given value till factorial. Okay, let's go solve this one. I'm going to type on my calculator 8 times 7 times 6 times 5. That gives me 1,680. I can divide this by 4 factorial, which is 1 times 2. That's 2 times 3. That's 9. That's 6. Excuse me. 6 times 4 is 24. When I divide this, I should never get a decimal in these type of questions. Yes. So my final answer would be 70. So there's 70 possible. Let's write the reason. Possible pizza topic combinations. Let me just write that. Anyway, you get the idea. Okay, that's the first one. What about the second one? Ooh, quantum mechanics. In quantum mechanics, a particle's spin can be described by the spin up or spin down. If you have 8 identical particles, how many different combinations of spins are possible when measuring their spins? Now, this is a very, very difficult question. I mean, maybe not that difficult, but when we have identical particle type of questions in quantum mechanics, there's a formula you can use, right? So it would be 2 raised to the n, where n is the particles. So n is the particles. So in this case, it's going to be 2 raised to the 8. So let's see, what is 2 raised to the 8? That gives me 2, 5, 6. But how do I solve this with combinations? Well, in this case, we have our first combination, which would be, if I spin, we describe the spin up or down with identical particles. So we can have the combination of 8 identical particles, and I need one of them. And we're going to do this for every single option we get, all the way up until the combination of 8 and 8. Now, how do I solve the sum of all these combinations? Well, for this, I'm actually going to use Pascal's triangle. So let's go find it. So 1, 1. I'm going to construct a triangle until we can find the 8th row. What's that? Remember, very important note, that whenever we work with Pascal's triangle, we always want to start from 0. Okay, so how do we solve this? Well, we add the two inner values together. So we have 2, then we have 3, 3, 4. Yes, 4, 6, 4. Then we have 5, 10, 10, 5. Then we have 6, 15, 20, 15, 6, then we have 7, 21, 35, 35 again, 21, 7, and then we have 8, what's that, 28, what's that, 156, 70, 56, 28, and 8. Okay, so in this case I have 8 identical particles and I need to find the sum of all these combinations. Actually I was supposed to start with 0, of course. So 0 and then moving all the way up until the 8 out of 8 combination, or 8 choose 8. So again, if we want to read this as 8 and 0, so 8 choose 0, right? Now how can I find these values? Well, I can go look at the 8th row, the 0th term. Then the 8th row, first term value. 8th row, second n, and then the 8th row, the 8th n. So I can look at all these values. And then I can add them together, right? So let's do that. Let's see. Well, we know our final answer should be, when we use this particle formula, our final answer should be 2, 5, 6. So let's see on a calculator. 1 plus 8 plus 28 plus 56 plus 70 plus 56 plus 28 plus 8 plus 1. And that does in fact give me the total sum of 2, 5, 6. Okay. Let's look at one more example over here. Let's say we have some students, right? Say we have 5 girls and we have 5 boys. Okay, so these are 5 boys. Now, I need to pick 2 girls and 3 boys. Okay? So let's go a bit down. So the question is, we need to create an R team. Let's actually use create an R team of equal members. And the R team need to consist out of 6 students. Okay. Now, what is the total possible combinations we can form with no... excuse me about that. Oh, hey. What is the possible combinations we can form with 6 students? Excuse me, the team, the R team. So we have 5 girls, 5 boys. So let's see. Equal amount of numbers. In this case, I can say, well, there's 5 girls, and I need to pick 3 of them, and we're going to multiply this. Let's add one more boy. Let's add one more boy. So let's make this 6. Okay, let's make this 6. 6 boys. So I have a total of 6 boys, and I need to pick 3 of them. Now we can solve this the mathematical way by saying 5 factorial over 5 over 3 factorial multiply 2 factorial. Remember, I'm using this formula. I'll add the formula in pink or in purple. Is this one? We have combination CR is equal to n factorial over n minus r factorial multiply r factorial. Okay, so I'm using this formula over here. We need to multiply this with 6 factorial over 3 factorial minus or multiply 3 factorial. What if I don't have a calculator? Let's go back to Pascal. So I need to find the 5th row and the 3rd term in the row. Now remember, we count from 0. So So let's go to my created triangle. So we want to find 5 and 3. So let's see. So 0, 1, 2, 3. So we have 10. Let's go put that in. 10. And we can multiply 10 by the 6th row, the third term. The 6th row, so 0, 1, 2, 3. So 20. Okay, 20. And then 10 times 20 is 200. So there's 200 possible combinations of picking the students. Right. Now, how do we know this is true? There's only one way to find out. Well, let's go do it. Let's go do it the long way. I'll do it over here. So we have, I'm going to simplify. I always want to try find the highest denominator, factorial, and somehow get the top value equal to the bottom value. So how do I do that? Is I expand the factorial over 3 factorial multiply 2 factorial. Let's solve for this one before we solve this one. Okay, so we see we have 20, the 3 cancels out the 3. We have 20 over 2, which is 10. Ooh, look at that. Hey, what did we do over here? Interesting. Let's look at the next one. We have 3, we have, I'm going to call this one B. Let's call this one A. So I put A over there, and I'll calculate B over here because I'm running out of space. So we have 6 multiply 5 multiply 4 multiply 3 factorial over 3 factorial multiply 3 factorial. Cancel, cancel. We have 3, or 6 times 5 is 30. 30 times 4 is 120. I need to divide 120 by 6. Not 6. Why is that? Because 3 factorial is equal to 3 times 2 times 1, which gives me 6. If I do that, I can break this up a little bit further. Let's actually get more technical by saying, well, 6 times 20 over 6, because 6 times 20 gives me 120. Cancel, cancel, and we have a 20. Ooh, where did we see a 20 earlier? Look at that, huh? Look at that. This 20 is now all of a sudden over there.